Okay, so this is 3.1b is in Bravo in college algebra, and we just finished example 1 in the first video, 3.1a, and the continuation of of example 1 in 3.1a is using your Excel spreadsheet program in the middle of the page and shows you how to put the formula in there and get your graph using Excel. You can also use your graphing calculator, put in the formula, and it will give you the graph as well. So lots of different ways to do this. I prefer you learn how to do it by hand because it gives you more of an understanding of what's going on rather than just plugging numbers into a calculator. And there's an example of me using Desmos, and I just typed in the formula right here and it printed out at the top of my phone the graph, the high point being 8, and see where it crosses here at -3 and at 1, and it looks all nice and pretty. So that's one quick way to check your work when you're doing these. I wouldn't depend on just being able to use your calculator and have everything work for you. But anyway, let's go on to example number 2, maximizing revenue. So here we go. Suppose the monthly revenue from the sale of Carlson 42-inch 3D televisions is given by the function, and there's our revenue function right there, where X is the number of televisions sold. Okay, we've talked about revenue before. A says find the vertex and the axis of symmetry of the graph. Determine if the vertex represents a max or a min point, and that will be determined on whether or not it opens up or down, and we can get that from that negative sign right there. Interpret the vertex in the context of the application, which means given the vertex and the story problem, what does that vertex mean? And then graph the function. E, for what x values is the function increasing, decreasing? What does this mean in the context of the application? All right, so we're going to do this in full just because this is all kind of new here, and we will just continue on doing these. All right, so this is my A, and my B is right there. And my C, I don't have anything. I don't have a C, so we'll just call that 0. And before I go on, let me make a correction here. There should be an X here. Okay, so remember it's AX squared plus BX plus C. C is when there's a number all by itself with no variable. There isn't one of those, so C is going to be 0 there. All right, so that being the case, we talked about whether it opens up or down, depending on whether or not the number in front of the x squared is a positive or negative. Since it's negative, it opens down. Talked about the vertex, or the vertex, yes. And I'm also going to talk about the axis of symmetry. I'm going to do the axis of symmetry first, because remember, the axis of symmetry is the x value of the vertex. So once we find that, we're good to go. Negative b over 2a. And that ends up being, when we plug numbers in, 3,000 is my axis of symmetry. It also means that my first number in my vertex, my x-coordinate, is also going to be 3,000. And so then to find the next part of my vertex, I take 3,000 and I put it in here for x, in here for x. I multiply that, or I square the 3,000, multiply by 0.1 plus 600 times 3,000, and that will give me my number for y, which in this case is 900,000, which means my graph is going to have to be bigger numbers. I can't just use 1, 2, 3, 4, etc. All right, so that gives me those 3 bits of information, and the third one that I want to, or the fourth one I want to look at is x-intercepts, or what we called before. Remember when I said the zeros of the function, where it crosses the x-axis. So, in order to do that, I take my formula right here and set it equal to 0. And I know it's going to cross in two places. All right, so factor that for, or solve that for x. In fact, let's just go ahead and solve that for x. So we've got this. I don't like having a decimal, so because this is in the tenths position, I'm going to multiply the whole thing by 10, and that will give me 0 equals negative 1x squared plus 6,000x instead of 600 if I multiply it by 10. That gets rid of the decimal here, makes life so much easier. I'm going to factor out an x, and I'm going to be left with negative 1x plus 6,000. And x then, in order to make this a true statement, again, in order to make this a true statement, whatever number goes here is going to be multiplied by here and has to equal 0. So any number times 0 is 0. So either x has to be 0, or this has to be 0. Negative x plus 6,000 equals 0. So negative x equals negative 6,000. And again, I want to change this negative x to a positive, so I change that to a positive. So x equals 6,000. So those are the two places where my graph crosses the x-axis. So here's the graph of the equation. It opens down. Vertex is at 3,000, 900,000. The axis of symmetry is 3,000. My x-intercepts are at 0 here and 6,000 here. And I was able to draw a smooth curve. So I've got my graph there. Now, being done with this, I can start answering some of the questions. It says find the vertex axis of symmetry. Did that. Determine if the vertex represents a maximum or minimum point. It represents a maximum point. Did that. Interpret the vertex in the context of the application. Okay, so what this tells me is that when I sell 3,000 TVs, I have maximized my revenue, because anything over 3,000, I'm making less revenue for some reason. I have no idea why. So I'm making more and more and more and more money until I hit 3,000 TVs, and then I start losing revenue. So that's the maximum that I want to sell. Okay. D, graph the function, which is right there. And E, for what x values is the function increasing, decreasing? What does this mean? Okay, so what x values? Which numbers here are showing that my y value is increasing? Well, from 0 to 3,000, they're increasing. From 3,000 to 6,000, they are decreasing. So on the interval, negative infinity to 3,000, I'm increasing, because this should have arrows on it. It really is continuing on into infinity. So from negative infinity to 3,000, and that should include, include the 3,000 here. And then I'm decreasing on 3,000 to positive infinity. Okay, so I guess it's not including 3,000. 3,000 is the turning point. So 3,000 is kind of a stable number. Okay, once we go past 3,000, that's when we're decreasing. Okay, so there you are. You could put this equation right here in your graphing calculator. It would graph that for you, and you'd be able to see the results without having to do all this work, but hey, that's part of the fun, huh? Okay, continuing on. Example number 3, foreign-born population. gives you the formula there, bottom of page 172. And gosh, basically you do the exact same thing that we have been doing. The number in front of the x squared is positive, so you know it's going to open upward. And you just follow the formulas or the method I showed you before for each one of these, and you'll be good. Example 4, it says a ball is thrown upward at 64 feet per second from the top of an 80-foot high building. Write the quadratic function. Now, how the heck are you supposed to write that quadratic function? Well, you look right above example 4, where it says s of t equals negative 16t squared. Okay, and it continues on with the formula that you'll use for a. Okay, so that is given there. So you've got the formula. Once you start plugging numbers in, and that's one of the things about this class, is you start learning how to plug numbers in. So we have s of t equals negative 16t squared. So I know this is going to open down because of the negative 16, which it should, because you're throwing a ball up and then it's going to come down, so it needs to be that shape, plus 64t plus 80. Okay, so there's your formula. Should not give you too much trouble there, and you're able to find the maximum height by finding the vertex, because the maximum height will be the y portion of the vertex. The x portion, you'll figure that out with negative b over 2a. You'll plug that answer, which is 2 in this case, into this equation, and you'll get a y value of 144. So you know that 144 is the max part, and you can get a lot of information there. And again, I would try it with your graphing calculator, and I would try to do it by hand as well, because there's information that you're going to need to do or to glean, like on a test or something, by doing it by hand, because it's good to have the actual numbers there. All right, bottom of page 174, vertex form of a quadratic function, and I am going to continue on with that in the third video.